Here's a slightly more involved circuit. We've got a number of series and parallel portions to it. Let's see what we can do with this. So we have 9 volts for our power supply. Again, we're going to start with the innermost setup. So we're going to start with this right here. So those are in series. So we have equivalent resistance of 10 plus 20 of 30 ohms. We can then look at this, which is in parallel. So my 1 over equivalent resistance here is 1 over 30 plus 1 over 5 plus 1 over 10. 30 is a common denominator, so we'll keep it as 1 over 30 plus 6 over 30 plus 3 over 30. So we get 10 over 30. We take the inverse of that, and our equivalent resistance for that portion is 3 ohms. Let's take a look at this portion here. This is in series, so our equivalent resistance here is 10 plus 5, or 15 ohms. Now let's take a look at this portion here. That's in parallel. So we'll put it up here. So 1 over our equivalent resistance equals 1 over 10 plus 1 over 15. 30 is another common denominator, so we're going to go 3 over 30 plus 2 over 30. That gives us 5 over 30. Equivalent resistance then for this is 30 over 5, or 6 ohms. So we're getting a little complex, so let's redraw our circuit. So we have our 9 volt power supply to a 10 ohm resistor, to our green 3 ohm resistor, to our purple 6 ohm resistor, and then back. So now we've got a much simpler circuit. It's a series circuit, so the equivalent resistance of this circuit is 10 plus 3 plus 19 ohms. So to find the total current, we're going to take our 9 volt power supply divided by our 19 ohm total or equivalent resistance, and we got 0.47 amps. Now we work from the outside in and go back and find the voltage and the current associated with each resistor. So for our 10 ohm resistor, it's all by itself, that's this guy right here, we have 0.47 amps. The voltage across our 10 ohm resistor is going to be the current, 0.47 amps, times the resistance of 10 ohms, so we get 4.7 volts. Let's look at our green parallel arrangement. Its equivalent resistance is 3 ohms, so the current coming into it is 0.47 amps. The resistance is 3 ohms, so the voltage for this portion, call it 3, is equal to the current, 0.47 times 3 ohms. So I got 1.41 volts across the green parallel arrangement. So that's 1.47 volts across the 10 ohm resistor. That's 1.47 volts across the 5 ohm resistor. And it's a total of 1.47 volts across the blue series of 10 plus 20. Within the green, if we want to find the current through each branch, we know the voltage across it, we know the resistance, so the current 10 ohm resistor is going to be the voltage of 1.41 divided by the resistance of 10 ohms, so we get 0.14 amps. The current across the 5 ohm resistor is going to be larger because the resistance is smaller, so again we've got the 1.41 volts divided by 5 ohms, and our current across the 5 ohm resistor is twice as big, or 0.28 amps. For the series portion there, that 10 ohm and 20 ohm resistor set, we want to find the current through that branch, and that current through the branch is going to be the same current through each of the resistors because they're in series. 2 ways you can do that. One way you can do that is to say the current through that branch, which is equivalent resistance of 30 ohms, is going to be the voltage across it, which is 1.41 volts, divided by the equivalent resistance of 30. I get a current of 0.047 amps. Another way I could do that is the current coming into that triple parallel branch has to split 3 ways. So the current through the first branch plus the current through the second branch plus the current through the third branch has to equal the total current. So I could also say the current through that branch is the total current of 0.47 minus 0.14 minus 0.28. If I do it that way, I get a current through that branch of 0.05 amps. If we're rounding to 2 decimal places, we're getting essentially the same thing. Does it matter which way you choose? No, it just means your answers are going to be a little bit different. Okay, so now I have the current through both the 10 ohm and the 20 ohm resistors. The voltage of the 10 ohm plus the voltage of the 20 ohm is going to have to equal that 1.41 volts. So we're done with the green, so let's move this out of our way here. So the voltage of the 10 ohm resistor is going to be the current through it, which is the 0.047 amps, times its resistance of 10 ohms, so the voltage there is going to be 0.47 volts. The voltage for the 20 ohm resistor, same current, 0.047 amps, times 20 ohms, I get 0.94 volts. If I add those two together, I should get 1.41 volts. All right, almost done. Okay, let's look at our parallel purple chunk up there. We have 0.47 amps coming in, so we can find the voltage across because we know the equivalent resistance. So the current across that equivalent resistance of 6 ohms is going to be 0.47 amps. The voltage across that 6 ohm parallel equivalent resistance is going to be 0.47 amps times the equivalent resistance of 6 ohms, so we get 2.82 volts. So that means the voltage across the 10 ohm resistor is 2.82 and the voltage across the parallel portion in red is 2.82 volts. So let's deal with the 10 ohm resistor first. The current in the 10 ohm resistor is the 2.82 volts divided by the resistance of 10 ohms, so I get a current of 0.282 amps. So the current in the other branch, which is the 15 ohm equivalent resistance, is going to be the 2.82 volts over the equivalent resistance of 15 ohms. I get 0.188 amps. I could have also said 0.47 amps minus 0.282 amps, and I get the same thing, 0.188 amps. All I need to identify now are the current and the voltages for the 10 ohm and the 5 ohm resistors that are in series. So for my 10 ohm resistor, the current is the same as going through that branch, so it's 0.188 amps. The voltage of that 10 ohm resistor is going to be current, 0.188, times the resistance of 10 ohms. So the voltage is going to be 1.88 volts. The current for my 5 ohm resistor is also 0.188 amps because it's in series. Voltage of my 5 ohm resistor is going to be that current, 0.188 amps, times my 5 ohm resistance. So it's going to be half as big. So I've got 0.95 volts. If I take the time to add those things all up, then I should eventually get my equivalent resistances, my equivalent voltages, and the total current.